Hello. Hi. Hi. Welcome to Homework Help 6.3. Okay. So it says in each problem there will be a pre-image and several images based on the given. There should be an N there. On the given pre-image. Determine which of the images are rotations of the given pre-images and which of them are reflections. If an image appears to be created as a result of a rotation and a reflection, then state both. Okay, so we're looking for, is it a rotation or a reflection? We're comparing all images to this guy. So our first one, this is our original image. This is our OG image. Okay, it's our OG image. All right, so to get from this guy to this guy, can we do so with a rotation or are we reflecting? Okay, you know that it has to be not just a reflection, okay, because I'm going from the rectangle being, so the top and bottom are the long lines to the rectangle being, so the shorter lines are the top and the bottom. All right, so that's not, there's no way this is going to be a reflection. Okay, so we've rotated this somehow because we go from here to here. So we somehow rotated it. Did we also reflect it? Let's see. Can I, starting here, see, I told you, if you want to just draw the shape and cut it out, then I think it makes it easier to see. Okay, so this is my OG image. Can I rotate my OG image to get to image A? So here's my OG image. Can I rotate it to get to this guy? Yeah. Turn. And now the dot lines up. So yeah, so image A is a rotation. Can we see that okay? Oh yeah, that works. Okay. So then once again, we're gonna try image B. We start out with my little pre-image. Okay, so I'm gonna bring him over here. Can we rotate so that we get to image B? Can we turn this so it matches up? Yes, we can. So this is also a rotation. If you didn't cut it out, that was bad handwriting. If you didn't want to cut it out, you could also rotate the paper. Okay, so here's my OG image. If I rotate my paper, well now this is image A. Okay, so I can rotate my paper around. So OG image, if I rotate it, this now becomes image A. Okay, if I start here and I want to get to image B, I'm going to rotate it the other way. And now I have image B. Okay, so you can do so by rotating your paper if you don't want to cut it out. All right, the third one, image C. So here's my OG image, right? Is there any way I can rotate this to get to image C? No. No. The dot's in the wrong spot. The dot needs to be up there. That's facing the wrong way. Now the dot's over there. Okay, I could line the dot up, but then that's not right. If I line the dot up, that's what I get. So no. So this one is actually a reflection. Let me put my OG image next to it. See how these dots are mirror images of each other? So you could say they're reflected over, there you go. They're reflected over the line. They're mirror images of each other. So this one is a reflection. Okay. And then image D. Okay. Can I get image D by rotating? Okay, so start here. Okay, if I rotate up, nope, my dot's in the wrong place. The only way this shape fits is if I'm like that, and my dot's in the wrong spot. Okay, but, so it's not a rotation. Here's my OG image, okay? Well, they're not reflections of each other either. They're not an exact reflection of each other. If they were exact reflections, right, then they would be like, oh, I'm on that reflection one. Then it would be like that. So the dot would have to be like right there. So this is both. Okay, you can also tell it's a rotation because I start out with my rectangle being horizontal. That's a better way to say that. I start with my rectangle being horizontal, and then it goes vertical, right? Then it goes up and down. So I rotate it, and then I reflect. So it's both. So it's rotation and, oops, there we go, and reflection. So it's both. It's both a rotation and a reflection. Okay. So for number 2, I don't think I'm going to go through all of it. Is it? No. Oh, there it is. Never mind. I'm not going to go through all of it. But on number 1, it was a rectangle, but so it's kind of easier to see with the dot. I would probably label the points on my triangle. Does that make sense? So if it's, that might be a good first step. So like, have this be point A. Okay, so these are right triangles. So this is my right angle. So A, this was A, and we'll make this be B. And so that makes this point C. Okay, I'm going to label all my triangles. So the one that's angle A is the right triangle. So that's here. That's my right triangle. Sorry, right triangle, right angle. Angle A is my right angle. And then the short side is from A to C. A to C is the shorter side, so this is C. This is B. Okay. Is there, you could, if it's gonna, we'll see if that helps you. If not, then don't worry about doing that. So is there any way I can rotate this triangle so that it fits on top of this guy? Okay, well, if I rotate my paper, because I didn't cut this one out, I guess I could use triangles that are just bigger. Okay, so this is my OG image. Is there any way I can rotate that so it fits here? All right, so that means, look, A is my right angle, so A has to be there. No, A has to be there because A is my right triangle. So this is A, my right triangle. I can draw it in. Oh, you can't even see that. Hold on. Wait. There. Okay, that's my right angle. So that has to be on angle A. So it's here. That doesn't fit. And that's, no. There's no way I can rotate this to fit this shape. So it's going to be a reflection. Okay. So you do that for all of them. Is there any way I can rotate my original image to match B, C, and D? So I'm going to go ahead and label the rest of these because I think it helps. So this is my right angle, so that means that's A. It goes, the short side is A to C, and so this is B. Okay, you could also rotate your paper. Can I rotate my paper so that this shape looks like this? Yeah, there. Now this shape looks like image B. Here, let me cover that one. If I rotate my paper, okay, now this shape looks like image B. So that is a rotation. Oh, I'm not writing this down. So this was a reflection. This is a rotation. I'm going to write it on the triangle rotation. Okay, so try C and D by yourself. And one of them is going to be both a reflection and a rotation. All right. The next part, right? Yes. Here we are. Here we are. Let me zoom in a little bit, hopefully. Okay, that's pretty good. So on each of the coordinate grids, there's a labeled point and a line. All right, so you have a point and a line. You have the point and you have a line. You're reflecting this point over said line. Okay, use the line as a line of reflection to reflect the given point and create its reflected image over the line of reflection. They said reflection like 5 times. So basically we're reflecting this point over this line. Okay, it tells you to use perpendicular slope. So we did a couple examples of these in class, all right? Let me see if I can zoom in a little bit more. Just focus on number 3. Yeah, there we go. Okay. So it says reflect point A over line M and label the image A1. Cool. Or A prime, whatever you're calling it. So the line that's going to connect A to A1 is going to be a perpendicular bisector. Perpendicular. Okay. So this line that's going to connect our 2 points is going to be perpendicular. So we have to figure out what the slope is. Okay. So it's going to be perpendicular to this line. So we have to figure out the slope of this line. I'm going to start, I like starting with my y-intercept. So I'm going to start with this point, and then what is my slope? It looks like I am going 1, 2, 3 over 1. Up 3 over 1. Let's see if I started at, where's another point? This is another point. 1, 2, 3 over 1. 1, 2, 3 over 1. All right, perfect. So my slope is 3 over 1. My slope of line M, let's do line M, the slope is 3 over 1. Oh, sorry. It's too far zoomed in. There we go. Slope is 3 over 1. So then you find, I'm going to be upside down, but I don't care. Whoa. Then you find that, I can't do it. Then you find the perpendicular slope. I don't know how to make a turn. Oh, wait, hold on. Nailed it. Then you find the perpendicular slope. Okay, so it's opposite over reciprocal. Sorry, it's opposite and reciprocal. All right, we're going to make a chart tomorrow and see if that helps. Let me bring this back down. Now it's mad at me. Chill. Okay. So, slope of your new line, which I'm going to do in blue, is going to be the opposite reciprocal. So this is positive, right? So to find the opposite, you make it negative. And then reciprocal just means flip it. So instead of 3 over 1, I have 1 over 3. Okay? So now that I know my slope, I can graph this line. So I'm going to go down 1 and over 3. That's what my slope says, negative 1/3. So I'm going to go down 1 over 3, 1, 2, 3. And then I'm going to go down 1 again over 3, 1, 2, 3. Okay, well that should be enough. Where's my protractor? Oh, where's my protractor? Oh, where? Oh, there it is. I mean, this is just so I can get a straight line. You can use a ruler. This is closer. Okay, there we go. All right. So these two lines are perpendicular. That means they form a 90-degree angle. All right. So we know that our point, because we're reflecting A, our new point is going to be on this line. So we dealt with perpendicular. Bisector. So they're going to be the same distance away. So the points have to be the same distance away from line M. So I have point A over here. So what point is the same distance away? Is this point the same distance away? No, that's way too close. Okay. This point is 1, 2, 3, 3 away. So this point also needs to be 1, 2, 3 away. So right here. So this is your, I guess I'm just right here. This is A1 is that point. I can give you the coordinates. Will that help? It would be at 1, 2, 3, 3, 1. Okay. Let's do another one of these. Hold on 1 second. Doesn't matter. I don't know that it matters. We'll do 5. Hold on, let me. Does that help? Not really. Okay. So for 5, we're going to reflect C over line L. So we have point C, which I will make be pink. I'm going to reflect this point. Okay. Okay, 5 and 6 are kind of annoying because their point is not exactly, it's like in the middle, right? It's at, this is 1, 2, 3, it's in the middle of 3 and 4. Okay. It looks like it is at -1 though. Unless I made that, hold on 1 second, let me make sure I didn't. No, that's right. So it's at -1. So this is at -1, but it's your x value is between 3 and 4. See how it's not exactly on either line? This is the 4 line. This is the 3 line. It's in the middle. Okay. So just be careful when you're drawing your lines. So you notice that. Okay. But anyways, it's not really gonna change what we do. So the first thing we're gonna do is find the slope of this guy. So the slope of our given line is, I'm gonna do it in pencil so I can erase it. Let's start here. Actually, I like to start by y-intercept. We'll start here. Start here. And it looks like I'm going, not yet. 1, 2, 3. 1, 2, 3, up 3, and 1, 2, up 3 over 2. Let's try that again. 1, 2, 3, 1, 2. Yep. 1, 2, 3, 1, 2. Okay, so my slope is rise over run. Can we see that? Yeah. So it rises 3 and runs 2. So that's the slope of line L. All right. It just becomes too much if I leave that on there. Okay. So then the line that connects point C to its reflected point is going to be perpendicular. So that's where you take the opposite reciprocal. So opposite would make it positive, so it's going to be negative. And then you flip it 2/3. Okay. So in using our slope, we can figure out this line. So I'm going to go up 2, no, sorry, down 2 over, okay, so it would be down 2, 1, 2 over 3. That'd be off the graph. It'd be like right there. That means we need to reflect over this line, so we need to go the other way. So go ahead and do the opposite of that. So instead of down 2, right 3, do the opposite. So I'm going to go up 2, 1, 2, and left 3, 1, 2, 3. Okay, up 2 again, 1, 2, over 3, 1, 2, 3. All right, connect my line. Oh, that point's not going to be correct. That's okay. We'll leave him off. Okay. So once again, these form, this is point C. There you go, point C. This is a right angle. They are perpendicular. Okay, so we dealt with the perpendicular part. Now we need to find a point that is equal distance away. So what point on this pink line that we just drew, is the same distance away as this one? Is it this one? No. This one's way too far away. It needs to be the same distance. This distance has to be the same. Okay. So it looks like that this guy is the same distance away. So that would be your C1. Okay, so it has to be on the pink line, it has to be on the perpendicular line that we drew in, and it has to be the same distance away. Okay. So try 4 and 6 by yourself. I told you you can skip 7 through 10 for now. Let's move on to wait. 11 through 16. Oh my goodness. There we go. Okay, it says slopes of parallel and perpendicular lines. Oh, wait. For each linear equation, write the slope of a line parallel. Slope, a line parallel. So this is just practicing with your slopes. So for parallel lines, what do we know about the slopes of parallel lines? What do we know about the slopes of parallel lines? Okay. For parallel line slopes are, oh, you can't see it, are equal. I have a little black dot on my finger. Okay. Parallel line slopes are equal. Okie dokie, okie dokie. So for number 11, all you're doing is writing the slope. You don't have to write a whole equation. So if I were to draw a line parallel to y equals negative 3x plus 5, what would my slope be? They're equal. So the slope of this line is negative 3. So the slope of your parallel line is also negative 3. Okay. Number 13, you have to finagle a little bit because we don't know what our slope is. So you have to solve for y. You must solve for y. So let me do that with you. So to solve for y, I'm just going to rewrite it. 3x minus 2y equals 8. Okay, solve for y. So I want to get y by itself. So I'm going to start out by subtracting 3x from both sides. So I get negative 2y equals 8 minus 3x. Okay. You're not finished. You want y by itself, so you have to divide everything by negative 2. Everything. Negative 2 divided by negative 2 is just 1, so this is just y. 8 divided by negative 2. What's 8 divided by negative 2? Negative 4, negative 4. And then negative 3x divided by negative 2. The negative and a negative, so you get a positive. So you get plus. Okay. If you want to rewrite it in slope-intercept form, you could just switch those. So it would be y equals 3 over 2x minus 4. Okay, so we solve for y, and then you pull out the slope. So your slope is 3 over 2. So this is m equals. So if the slope of this equation is 3 over 2, for a parallel line, the slopes are equal. They're the same. So 3 over 2. Okay. 14 through 16. Now you're just doing perpendicular. So that's that opposite reciprocal. Okay, so for instance, I have negative 2/7. So the opposite of that is positive 2/7, and then you flip it. So you get, it's going to be, if this is a negative, then your new slope for a perpendicular line is going to be positive. So positive, and then flip it, 7 over 2. Okay, number 16, you're going to have to solve for y like we did on number 13. All right. I think that I will leave you there. You can skip 17 and 18 for now.